Good day and welcome to lecture 6 of SLK 753. Today we're going to look at systems theory, but we only will be looking at the most salient concepts of this theory. So you might ask yourself, as a community psychology practitioner, why do we care about the systems theory in community psychology practice? Well, my answer is it is because successful community-based interventions require that change agents, and in this module you will be the change agents, have to give attention to both the core system, your intervention community, and the peripheral systems. So those are the systems surrounding your intervention community. This can result in quite a complex setup. So many community interventions have failed because of reductionist thinking, including looking at simple cause and effect relationship between causes and problems, and I put that in inverted commas. This narrated PowerPoint will give you a brief overview of the basic concepts of systems theory, with special attention given to some of the concepts described by Uri Bronfenbrenner. This narrated PowerPoint will not be enough to have a good understanding of systems theory concepts. It's necessary that you do more research and read more literature. In the study guide on page 8 and on ClickUp under lecture 6 and 7, I have provided links to many journal articles which you'll be able to read more about systems theory and how it can be applied to understand specific community problems and solutions. So I strongly suggest you read these articles to help you conceptualize the needs and the resources of community, and specifically your community, and to guide you to do a systemic assessment of which type of intervention will be most useful for your target community. I want to highlight that your aim is to implement an intervention that will result in some systemic shifts that will benefit your target community. There are many of these levers for change that can be targeted at many levels of a system. One type of change lever we are all familiar with is policy change, but that is at a higher systemic level than you will be intervening at. There are many other types of change levers that can trigger shifts across system components, such as shifting system components or members, strengthening or expanding relationships within systems or across system boundaries, bringing in new or different resources, changing existing practices, shifting the rules of a system, or changing system members' mental modes. Some of the articles I added on ClickUp come from these two journal issues. I suggest you have a look at some of the other articles in these issues in addition to the articles I referenced in the study guide. You can also read in the Journal of Community Psychology and search with the keyword of systems. The only way you can develop a systems perspective, thus a lens through which to view your community psychology practice, is to research, to read, and to learn to apply theoretical principles to actual real-life situations. This narrated PowerPoint, again I will reiterate, is not enough for you to gain a good understanding of this length. So you are required to do a lot of extra reading. So systems thinking allows us to have a macroscopic view of our community intervention group. So instead of looking at an individual with a microscope, which helps us to understand everything about this individual, but we have a very narrow view. Think of the DSM-5's view of individuals, which are basically constellations or clusters of symptoms. It's a very narrow view. But a microscopic view helps us to look at a community intervention group as they function within their context. And we also look at how their context functions. We are also interested how the community intervention group and the context influence one another. So maybe a diagnosis through a blood test versus a full body MRI scan as a diagnostic tool is a good metaphor for the difference between a reductionist or a systemic lens. The blood test looks at a very narrow constellation of things, whereas a full body MRI will have a big picture or macroscopic view of the person. So remember that systems theory is an umbrella term, and there are many different types of systems theory. All adhere to basic principles, but each theory highlights something specific in order to facilitate building knowledge and systems change in a specific context. A number of scholars have contributed basic ideas to the ecological perspective. Ludwig von Bertalanffy was one of the early founders of what is now known as the general systems theory. This is a theory that focuses more on interrelationships between elements that together form a whole. He was a biologist, so he looked more at ecological, and so he had a bit more mechanical and reductionist view of systems. But his ecological perspective was expanded on and adapted by other scholars. For example, Barker has a social ecological approach, and Kelly has an ecological approach to community psychology. But I'll make mention of two scholars, and I will highlight of what the theory focus on in the next slides. One of the pioneers of ecological thinking was Barry Commoner. His 1971 book, The Closing Circle, suggested that the American economy, which is a system, a complex system, should be restructured to conform to the unbending rules of ecology. So if we look at ecology, it's nature, you know how complex nature and interdependent all the different organisms in an ecology is. So Commoner proposed that an eco-socialist response to environmental degradation is a more realistic approach to sustainability than the economical limits to growth theory. So his four laws are written on this slide. So everything is connected to everything else. So because we all live in one ecosphere, what affects one affects others. The second law is everything must go somewhere. So there's no waste in nature, and there's no way to which things can be thrown. Unfortunately, what we do in life is we throw stuff away. It goes to, what do you call those things? Landfills, where we keep our rubbish. We try and recycle some, but there are things that are unused. He said in nature, the way things are structured is as soon as something dies, it vitalizes other areas of the ecological system, and that our thinking about ecology and economy should be similar. His third rule is nature knows best. So technology is supposed to improve nature. We use technological interventions to improve the simplicity of nature. But our technological interventions often are detrimental to the original system. What that basically means is that often if we follow the simple rules, often the ways we try to fix simplicity actually is more detrimental than following simplicity. And the fourth one is quite funny but very meaningful. There is no such thing as a free lunch. There are no action that is without consequences. Exploitation of nature or the original will inevitably involve conversion or the transformation of resources from useful to useless. If you think of where we start, how we end up with plastic and what we started off, what it started off as in South Africa, for example, we have coal, we translate that into petrol, and petrol can get translated into plastic. So as I describe principles of systemic thinking, you'll see later on how Commoner's 4 laws are present in community psychology practice. So let's look at Bronfenbrenner's developmental approach. Uri Bronfenbrenner developed a framework for understanding human development from an ecological point of view. So just think about the type of developmental theories we had in the 1970s. We had very reductionistic and narrow sort of theories. For example, we had Freud's theory or Erikson's theory that depended on discrete steps that had to happen. He looked at the macroscopic view of human development. So his 1977 and 1979 articles describe the first wave of his theory, which was later expanded. So according to Bronfenbrenner, the development of individuals needs to be understood within the context of environmental systems which they are part of. Bronfenbrenner's bioecological theory of human development conceptualized the environment in terms of nested systems ranging from individual to the chronosystem. As you can see on the little picture I have on the slide, from the inside, you are the developing individual. We have the microsystem, the mesosystem, that are the interactions between microsystems, the ecosystem, macrosystem, and the expression of time, change over time, which is in the chronosystem. He emphasized that the developing individual and all the other systems are connected to one another, and therefore they influence one another. This theory gives a good framework by which to understand ecological influences, not just on developing individuals, but also on other units of focus. It has been used, this theory has, for example, been used to understand what happens in schools, in classes, also in companies, where the company could be the developing individual. And you and your targeted community, your unit of focus can be the community that you're going to do your intervention on. So instead of the developing child, you can conceptualize all the environmental influences on your group by using Bronfenbrenner's functional framework of levels. So when I say functional framework, or I could call it structural framework, it's all the systemic layers like micro or mesosystem. Just to remember that your focus is not only on this structural level of just the systemic layers, but also on the bidirectional and multidirectional interactions and relationships between elements and all the systemic levels. Okay, if you don't understand what I meant, the next slide we will look at the principle of interconnections and relationships within a system. Okay, so if you look at the slide, we still have exactly the same levels or the systemic layers, but now all these arrows are included to show you the relationships and the directions of the relationships. So on this slide, on Bronfenbrenner's theories, on this slide, the arrows indicate all the bidirectional and unidirectional interactions between various elements in the larger system. For example, here you can see the child interacts with various individuals in the health services, in their family, the school, and the peers in their microsystem. There are also interactions between the child, individuals, or groups within each microsystem. So this is the mesosystem. The teacher at school that interacts with the child and also interacts with the child's friends at daycare and the parents of all the children at daycare, for example, will form a mesosystem. So we will be interested then in how the microsystem and mesosystem bidirectional interactions influence a developing child. But the ecosystem, macrosystem, and chronosystem is also at play at the same time. For example, how does extended family issues influence the parents of the child? Because it will have some influence on the child. What about culture plays in on these interactions between extended family issues, the child's issues, the child's family, and the child's interaction with the teachers? So we're asking, how does the chronosystem, the macrosystem play a role there? So this is important to note. It's important to remember that while the characteristics of the system components, so the child, the school, the teacher, or your group members are important, with system thinking, it's more important to note the type, the nature, and the frequency of interactions. Because it's the interactions that creates the system. If you think of your body, it's the interactions between all the different systems in your body. You have a digestive system, you have a breathing system, you hopefully have a thinking system, that's your brain. And we're interested, your body cannot be just one of these parts. Your body is your body, or you are you, because of the interaction of all these parts. So interactions in systems, social systems, create new behaviors, functions, subsystems, or systems. And that is why we say a system is more than the sum of its parts. I want to give you one very interesting example of how a system can be more than the sum of its parts. If I look at just a group of a colony of algae, which is a very simple cellular organism, there are examples of specific types of algae that you can move through a maze to find food. They move by themselves. So although each algae is a very simple organism, and there's no leader algae. So there's no commander or leadership in this colony or group of algae cells. Scientists were able to move this whole system through a maze by placing food at specific places in the maze. So the goal-directed movement of this pack of algae was because of how these individual algae little organisms communicated with each other, and that made the whole pack move. So that is why the whole system was more than the sum of its parts. We can also think about the internet. Nobody started the internet, although we can pinpoint the first individuals and organizations that experimented with virtual connections between PCs to create a network. The network we now have was not planned. It emerged from interactions over time between all the individuals, organizations, governments, technology changes, and it did not develop from anybody or an organization that decided that this, what we have now, is what it should look like. And a third very profound example is if you think of your brain. If you look at your brain, or you look at someone else's brain with a microscope, you will see it consists just of many different types of different neurons. So it's just cells connected with one another, and there are chemical reactions that make certain things happen. Yet from these interconnections between the neurons and all the chemical reactions between the neurons, your intelligence and your personality emerges. This again shows that a complex system is more than the sum of its parts. Something new emerges from the interactions between some system components. And if you think of your brain, even stranger, it is with the product of the interactions between neurons, intelligence, that the brain was identified. So the interactions between the cells in the brain identified the brain as the seat of the intelligence. And it's this intelligence that's the product of the sum of the parts of the brain, named this collection of neurons the brain. So something totally new emerged just from interactions between the system. So remember that we said it's the strength, the nature, and the frequency of interactions that create the system and subsystems. So if you look at the left-hand side, you can see there's a system with boundary around it. So there are components within the boundary, and there are components without the boundary. So if you look at the boundary, it's sometimes very important to know which system it is you're looking at exactly. So maybe that boundary could then be your group, and each component would be a member of the group. or that boundary can refer to the microsystem of the specific clinic you're working at. And so one component would be the group, one component would be the staff, one component would be other clients, and another component could be you. So it just depends where you draw the boundaries for you to understand which are the components inside and outside the systems map. Okay, so if we look at the on the left hand side, and maybe then within the boundary would be the SLK 753 class. Okay, so those are all the people in the class, and on the outside there are components like Jacques and myself could be a component. Others, honors lecturers could be a component, and maybe the library would be one of the components that is outside the boundary, and inside the boundary is your class. But if you look at the right hand side, you'll see when we start looking at interactions, some of these interactions are bidirectional, some are just unidirectional. Then we start seeing what happens when there are influences that is exerted through interactions. So if within the 753, SLK 753 class, some individuals interact more often and in a more friendly manner with other individuals, they will form a little subsystem within the larger class system. So maybe if you can look at the component at the top, the left and the bottom, you see they interact with one another. Maybe we can draw a boundary around them and say, there's a little subsystem. There's a little group. You know how we speak of we're all in the same WhatsApp group? It means we have something in common and that we interact more. That could be a subsystem. So a similar thing you would be able to see. So as you can see in your class, maybe that you have little subsystems, little groups of friends within the larger subsystem. You may observe in your intervention group exactly the same subsystems. And even in the environment, among the healthcare providers, which little subsystems are there? And this you can only see by looking at the strength, the nature, the type, and the frequency of interactions between system components. So if you start mapping the interactions, then you'll start seeing the subsystems or the elements with a lot of influence. If you look at some of the components outside the subsystem on the influence diagram, you will see that the component on the left, two components on the left, seem to have different types of interactions than the one on the outside, on the left hand side, that just feeds into the subsystem. Okay, so it is therefore important to understand what type of interactions are happening and what the contents of these interactions are. Is it verbal? Is it non-verbal? Is it energy? Is it information? Is it physical stuff that gets carried across in this interaction? So remember then, if you look at the interactions, you also have to understand all these things about the interactions that I just mentioned. Another important part of systems thinking is to understand feedback loops. There are positive and negative feedback loops, as shown in this picture that reflects the general systems theory. Remember that I said the GST had a more mechanistic view of biological systems. That was the hallmark of the Newtonian science. And it regarded feedback as a neat little concept of how a system deals with output from the system. For example, if you've seen the video of the diver in Algoa Bay that ended up in a whale's mouth, we consider feedback in this way if we look at this diagram. The whale opened its huge mouth to get as many sardines from a bait ball as it can into its mouth. Okay, that's the input. It then realized that it couldn't close its mouth because the diver was stuck in its jaws. That's the process. And then its brain gave feedback to its mouth. And it's opened its mouth to let the diver go. That's the output. So that was the feedback loop with this whale. And maybe the whale will, for now, he will check out first if there are any divers in the bait ball before he goes and just tries to swallow a whole bait ball. So this is a simple example, but now we'll have a more in-depth discussion of feedback loops. I just want you to look at this picture that you can see there's a continual feedback loop between input into a system and its output. And this, in the next slide, we'll look at positive and negative feedback loops. Okay, so if you look at the middle, it's very clear is that there's an action, the arrow goes to an effect, and the feedback from the effect feeds back into the action. Okay, so that is at the simplest point how we can describe a feedback loop. If you look at the bottom left and you look at the thermostat example, what happens with the thermostat? We don't use them that much in South Africa, but a thermostat we set at, for example, 21 degrees. And we'll say that that is what it needs to be. This room needs to be 21 degrees. The thermostat will the whole time measure then the temperature of the room, and as soon as the room reaches 21 degrees, it will switch off. And then as heat dissipates and it grows colder, as soon as it goes under 21, it reads, the feedback reads to the thermostat that the temperature is under 21. And for example, and then it creates a gap. That gap leads to the thermostat switching on again. Okay, that's a feedback loop, and it's a simple feedback loop. In social systems, it's much more complex. Okay, so the first thing you have to understand about descriptors, positive or negative feedback, those qualitative, positive or negative, does not refer to the quality. Positive feedback is not necessarily good feedback, and negative feedback is not necessarily bad feedback. Positive feedback means that whatever input, when it goes into the system, is reinforcing what the system is already doing. The system will therefore repeat what it is doing. Let me say that again. Positive feedback means that whatever input that is going into the system reinforces what the system is already doing. The system will repeat what it's doing. So success is a good example of positive feedback. If you realize reading journal articles, the input, improves your test performance, the output, you will read even more journal articles. And this will increase your success. And so because it increases your success, you are likely to read even more journal articles. So that is what I mean. It reinforces what you're doing, you're reading it, you get success from it, and because of that, it will reinforce reading articles, reading what you're already doing. In larger, more complex systems, positive feedback can accelerate the output-input feedback loop so that it can lead to emergent behavior that brings the complex systems to the edge of chaos, which is not a bad thing. This is where new innovative behaviors emerge. Think, for example, of how the Feast Must Fall movement changed between 2015 and 2016. Success, okay, so that's good reception by students and academic staff in 2015, accelerated change in the system. But what happened was that the changes took place, and the Fallist movement in 2016 looked very different from the one in 2015. Because success accelerated change. It brought some instability, but it also brought growth. On the other hand, negative feedback has the function of balancing or self-correcting the system. It thus reduces or de-accelerates changes in the system. One example is the Chinese one-child policy. Couples who had more than one child received all sorts of feedback that made it likely they will de-accelerate the reproduction For example, they would then have less children. They would not try to have more children. For example, there were lack of health care for the second or the third or whatever child, and they would also get fines after after they've had the first child. So from the second child on, they would be fined. So that then hopefully made that the system reconsiders their behavior and says, well, is this useful? Is this what we want, the output? Is this what we really want? If they decide they want more children, then they would carry on, because then the child was actually the positive or the reinforcing feedback. If they decide, no, 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 I don't want fines and I don't have enough money to pay healthcare, then it would balance or it would de-accelerate change. It would make that they would not make more babies. So couples who only had one child, again, receive positive feedback. So they would get paid health care, they would get vouchers, and so that would reinforce their behavior. So it was positive feedback for them not to make babies. So can you see how negative and positive feedback can mean different things, and how you can know whether something is a positive or negative feedback loop is to see, is the behavior accelerating or is the behavior de-accelerating, or is it to try and create balance and stability in the room. Often when I ask questions in class, everybody looks away and nobody wants to answer the question. So then I just keep quiet. So let's think about it. Is my quiet positive feedback or negative feedback? So staying quiet is actually positive feedback, because what happens is students remain quiet. So it accelerates the silence. It carries on with the silence. I hope that helps to understand you a bit better about how to understand whether something is positive or negative feedback. So this picture is a systems map that maps the positive and negative feedback loops in a campus water supply and use system. What is very clear from this picture, even if you don't understand the actual feedback and system components, which I don't, is that there are huge feedback loops at play from systems that could be far, far from apart if you can look at the components. In all complex systems, and social system is a complex system, feedback loops result in circular cause and effect relationships. This is also referred to as non-linear cause and effect relationships. Linear cause and effect means that we have a clear relationship between cause and effect. We know a certain type of virus causes a certain type of illness. Circular cause and effect, on the other hand, means that small causes can have huge effects, and huge causes can have small effects. So a big drug raid, a big drug raid in some Sunnyside may not actually result in a decrease in the selling of drugs and the use of drugs in Sunnyside. But a relatively small intervention at grade 1 level at schools in Sunnyside may have a huge effect on drug use by adolescents once those children have grown up. So also to know is that one effect may have many interacting causes, while one cause may have many unexpected effects in the larger system. Let me repeat that. One effect may have many interacting causes, while one cause may have many unexpected effects in a larger system. So the same intervention cause may have different effects in different systems. And different interventions, so different causes in multiple systems, may have the same outcome or effect. So you have to keep the idea of circular and non-linear cause and effect in mind whenever you plan your intervention. Make sure you don't have a linear cause and effect relationship in mind when you develop it. Okay, so remember, Commoner looked specifically at how the global ecological system gives us principles to evaluate other complex systems. So these four laws that he had also can be applied to complex social systems. So I indicated on the slide, and I suggest you pause this video. Make sure you understand exactly how these laws can be seen in a more complex and social system. Okay, so we get to the reflection part, and this is going to be important because this is something we expect you to include in your group assignment as part of the systems formulation of your community intervention group and their context, and so also how you derived at your specific intervention. Okay, so what this what this slide shows is that there are many ways in which you can map a system. So the behavior over time, I don't think you have to worry about that one. There's the iceberg model. You can also turn it around, but what it says is that events, many different types of events, leads to patterns in behavior or patterns in how system operates. Many patterns result in structures or specific ways of, if you think of schemas, of way that we actually look at the world. And then underlying that, all these structures contribute to mental models. That's the iceberg model. I can also do it right from the bottom can be cell, and if you put lots of cells together, instead of structures, I would write organs. If I put lots of organs together, then maybe I get a body, and if I put lots of bodies together, then I get a family or a social system or a human being. The third one looks at causal loop diagrams. I've already discussed it to you, and it's very, very important that you learn to look at causal loop diagrams. You can very clearly see here it refers to circular causation, where I said that the cause can be the effect and the effect can be the cause, and it can take more than one cause to result in a specific effect, or it can take one effect can lead to very many different causal effects. Okay, and another very useful way to look at system is to connect all the elements. Okay, so each system would have elements in it. So those dots you see, A, B, C, D, E, that are the people in your maybe your group, and it shows all the types of interactions that you saw that took place during your needs analysis. So you can in this way start seeing, do you have subsystems in my group? Who are the leaders of the group? Who are the quiet ones? Who are the ones that come up with the great insights, but they're quite quiet? We can also say A is my intervention group, B is us, C is Amanda and Jacques, D is the university and the rest of my honors module load, E is my family, E is my own biological self and how much I can do. And you can look at interactions and the types of interactions and causal loops between them to help you understand what is happening in this system within its environment. Okay, so I'm going to give you step-by-step instructions, what I want you to do. So please listen now clearly, okay, with both ears. So step 1, draw a map of your community intervention group according to Bron van Brenner's systemic layers or levels. So your group, so that's the community intervention group, will be your target unit instead of the developing individuals. From your knowledge gathered in the needs and resource analysis, which microsystems do they interact with? So you will write down your group. Maybe you'll make little circles for each of the group members. If you have a specific group member, if you have specific group members, maybe you have an existing group. Maybe you don't know Maybe there aren't formal existing group members. Maybe it is a transient group. Whoever wants to come monthly can come to this group. But you also will write down the microsystems that are involved outside. Okay, so maybe the healthcare staff at the clinic, their families, their friends, their work. It could be you. So all the systems, microsystems that your group interacts with. Okay, so now you also have to look at the elements in the ecosystem. So remember the definition of the ecosystem before you can decide really what is in play there. So those are system components that play a role in the lives of your specific group members, but they don't have to be present in that specific layer. Okay, so it could be the meeting that Jacques has with everybody, all the psychologists that are in the clinics. That group could actually influence your group without your group members being present in those actual meetings. Okay, so also look at the macro system components and elements. Policies, laws, belief, cultural aspects, stereotypes, socioeconomic issues. Which of those have an impact on what is happening in your group? And remember, that could be information you gathered from your needs and resource analysis, but it also would be from just what you saw and understand of South Africa or of this context. So you also want to look at the chronosystem. Which changes over time is influencing this whole ecological system? For example, have mental health care services deteriorated or has it improved over time? And does this change over time influence the target unit, your group? Are there biological factors that have changed over time? Maybe your group works with people who are senior citizens, and maybe that has played a role, that the older they get, something happens in their interaction with the rest of their ecology. Okay, so that was all in step 1. Step 2 is we start adding the different types of interactions between all the system components in your system maps. So that's when you're going to start linking all the system components. Reflect on the type, the strength, the nature, the content, and the frequency of these interactions. Do you see any components, subsystems, systems emerge that have a strong influence on your group? What is the effect of this influence? What emerge from these influences and interactions? What makes this system more than the sum of its parts? Maybe all your group members are as individuals responsible and they're able to set goals for themselves on how to stop abusing substances. But in the context of their group's interconnectedness, they create or produce a group think that's larger than the sum of the parts. And this desire to abstain is reduced because of this groupthink. And they are more likely now to go and abuse drugs. So obviously you can see there are feedback loops involved here. So you also need to start identifying the feedback loops in this step. So you might just start writing down the short different types of interactions, and then you'll be able to start seeing patterns and groupings of interactions. And you'll be able to start seeing the longer loops, or it can be shorter feedback loops that start happening. You also need to indicate and understand whether these feedback loops are positive or negative. Okay, so now the third step is, now you need to try and find circular causal feedback loops as it relates to what you developed as a need for your intervention community. Okay, why I say circular causal feedback loops is so to stop yourself from thinking in linear cause and effect relationships, and you have to start recognizing that there is no clear cause and effect. So for example, you may have decided up to now that your group doesn't have assertiveness skills, and that is why they feel isolated. They're not asserting their needs. But after you've done this system mapping, you realize that their lack of assertiveness has multiple causes emerging from various systemic layers and components and groups of interactions. So once you have a macroscopic view of the need or the problem, you can look at whether intervention will be more effective. Maybe your group feels isolated because their families have not been educated on mental illness and how to support a member with chronic mental health issues, because there's a cultural stigma against mental health illness, because the mental health education system is so overwhelmed and they're under-resourced. Because of that, they are not able to help the families as well. There's not time for family therapy as well. Another reason could be because of their socio-economic implications. Maybe in this community, people are working blue-collar, low-power, blue-collar jobs. Because of that, they can't just take time off to go to the clinic. They don't have enough power to say, hey, I need an afternoon off to go and find out about my brother or my son or my mother's mental health illness. So it could be an interaction of all these factors that results in a confluence of isolations, feelings of isolations of your group members. So then your intervention can maybe to support the group. You will empower the group to develop a pamphlet that they can give their families on what is mental health, how does it develop, how is it linked to their cultural understanding of certain things, what are the things that can make mental health difficulties better, what can be expected from the family, how to better support a person with chronic mental illness. And can you see, this is a very different and a more empowering intervention maybe than just teaching assertiveness skills. And that is because you saw the systemic picture. So you saw the macroscopic view of this problem. So now this is very important, and I'll remind you again. We expect you to include this systems map in your group assignment as part of the systems formulation of your community intervention group in their context. So in the next narrated PowerPoint, we will look at the skills and abilities community psychology practitioners who operate from a systemic perspective should have. So enjoy getting to know the systems theory. It's extremely useful theory, and once you have this lens, it will change the way you see the world and also your effectiveness in the world. That's what I believe. Goodbye.